Hello everyone! Welcome back to our Lee County Library Science Club. It's great to have you with us once again. Just a reminder, please make sure you have your parents' permission and some supervision when you're doing these experiments with us. So it's March, right? And in March we celebrate St. Patrick's Day. And on St. Patrick's Day, what do we wear? Green! That's right. And there's something science related that we can make that's green. It's also sticky and gooey and really fun to play with. You know what that is? Slime. Today we are going to make some nice green slime. And because it's St. Patrick's Day, maybe we'll add a little bit of gold to our slime. In thinking about slime, I want to focus on the chemical reaction that creates the slime. Now we have talked several times about different chemical reactions. What they do, what they can look like, some different ways that chemical reactions can happen. But what I want to demonstrate with our slime is what a chemical reaction actually is. So we're going to do that by comparing the chemical change that happens in a reaction to physical changes that can happen without a chemical reaction. So we're going to compare chemical changes to physical changes and use our slime to demonstrate some of those. So first, let's try to define what these things are. A physical change is anything that alters the shape, temperature, state, or composition of a substance. And that is as opposed to chemical changes, where we're actually altering the bonds between the molecules to create an entirely new substance. So how does that actually look different? Well, a physical change happens like when you make a smoothie. Okay? You cut up different kinds of fruit, you put in some ice, maybe some yogurt, maybe some milk, however you like your smoothies. And then you chop it up and blend it all together, and it looks like it's a totally new thing, right? I mean, you went from having all these different ingredients to having just one substance with them all mixed together. But none of the chemical compounds within that have actually changed. You've just cut things up really small and mixed them together so they're all kind of on top of each other. But if you put in a lot of time and effort, you could actually separate it all back out into its component parts without doing any special processes. Now obviously you need a microscope to pull every little fruit molecule out of there, but you could actually do that. Some other examples of a physical change would be like freezing or boiling water. The molecules themselves are still water molecules. They're still H2O. A similar thing is happening like if you're doing baking and you mix all the dry ingredients together and you mix all the wet ingredients together. Again, you're just mixing things. You're not actually changing the chemical structure of those substances. So what does it look like when we change the chemical structure? When we create a chemical reaction? What are some examples of those? Well, that happens when you take what you've mixed up and you actually put it in the oven and bake it. Heat is what's sometimes known as a catalyst, which means something that pushes or drives or makes happen a chemical reaction. So when you take those mixtures, put them together, and add heat to them, then it's actually breaking bonds within the molecules and recombining the atoms into new molecules. So believe it or not, when you bake, brownies or a birthday cake or something, you're actually doing chemistry. You are making a chemical reaction between those compounds to create an entirely new substance. This also happens when things rust, right? If you look outside, maybe on your car, maybe there's a fence around or something, you see some metal with that flaky orange brown stuff on it, that's rust, right? But rust is actually a different composition of molecule than whatever that metal was. So most of what we see as rust is normally iron. It can be just plain iron or an alloy with iron and a small amount of some other metallic atoms, but it is basically iron. When it starts to rust, that is what's called oxidation. And that flaky orange-brown stuff is iron oxide. It's not iron anymore. It's a different substance. And that's why it breaks so much more easily and why it looks so different. Because it's actually had a chemical reaction where the iron bonds have been broken and combined with some oxygen molecules to create iron oxide. This also happens when we burn things. If you take a piece of wood and you light it on fire, what happens at the end of that log burning? Are we left with wood molecules? No, right? We have carbon in the form of ash or charcoal, and we have carbon dioxide that comes out in the smoke. So, we're going to demonstrate this as we make some slime. Now, to do this experiment, you're going to need some water, some Elmer's school glue, or sometimes they call it PVA glue. You'll probably want some food coloring and glitter maybe to make it fun and pretty. We need some baking soda, and the thing that will really make our slime happen is some saline solution. It's normally used to keep contacts wet, but just make sure you look on the back and that it says it contains boric acid. Okay, we need saline solution with boric acid. If it doesn't have that, it's not going to work. And then at the end, we're also going to put some shaving cream in it to make it really fun. Alright, are you ready? Let's get started. Alright, first, let's demonstrate some physical changes. We're going to start with our glue. You're going to need to measure out about half a cup of glue, which for me is going to be this whole 4-ounce bottle. Alright, next we're going to add half a cup of water to it. Okay, and then we're going to mix that together. As we mix the water and the glue, let's think about, is this a physical change or a chemical change that's happening right now? Well, the glue, as we said, is PVA glue, meaning the molecules are polyvinyl acetate. Polyvinyl acetate is a polymer, which means it's just long, long chains of the same molecule repeating over and over again. When we add that with water, the truth is, no, there's not really a reaction that's happening between the water molecules and the PVA molecules. All that's happening right now is the water is mixing with those polymer strands. So we're getting some more space between the polymer strands, right? They're not as close together as they were with the glue, which is why it's much runnier than when it was in the glue bottle. But it's still just PVA and water. We haven't created anything new yet. Once we've got those mixed up pretty well, now is our time to add our fun colors. So as we said before, it's March, it's St. Patrick's Day. Let's make our slime some nice, bright green. Now again, as we add this, are we creating something new? Are we causing a chemical change within this substance? Well, the answer is, again, no, we are not actually. The food coloring that I'm putting in here is just some dyes with a little bit more water in it. We are dyeing the PVA molecules a new color, but again, we're not actually changing the chemical structure of them. So those polymers are still there, they're just now green. And as I said before, it's St. Patrick's Day. Why don't we add some gold? Now, once again, this is still not a chemical change, right? This is just creating a different kind of mixture. We're adding some gold glitter into the mixture, but it's not going to react with anything, and it's not going to create a new substance. And I want some more glitter in there. Let's make it really fun and shiny. Alright, so we've mixed together the glue, the water, the food coloring, and the glitter for some nice green gold mixture here. Now in our other bowl here, we're going to create a different mixture. We're going to add a little bit less than half of a teaspoon of baking soda and 1 full tablespoon of our saline solution. We're going to mix those together. Now the question here is this going to be a chemical reaction or a physical change? Well, this is still not a chemical reaction. We're just creating a solution of the saline boric acid and the baking soda. And what's happening here is the baking soda, once we put it into this, is going to help the boric acid create the reaction. Alright, so we've got our two pieces. We've had physical changes so far, right? This looks very different than what we started with back here, but it's still not a new chemical substance. We haven't changed the molecules within. But now, as we take our saline and baking soda solution, we pour it into our glue and water solution. We're going to mix it up, and we're going to start to see a real change now. Okay, you can already see it's starting to get a little thicker, right? Now what's happening here, we talked about the PVA is polymers, right? Those long chains of repeating molecules. And before, when it was just the PVA and the water, well, those long chains just kind of, hung out together. Now as you do this, you may need to kind of get into the middle and really pull it apart to make sure all that boric acid is mixing with the rest of the material. And this mixing might take a little while. As I was saying, the PVA is long chains of polymers. Well, as we mix in the saline solution, we said that's boric acid, right? Well, the boric acid starts to separate into borate ions, which if you remember from a long time ago, an ion is a charged particle. So those charged particles start to intermix with those chains of polymers. And instead of the polymers just kind of resting next to each other and sliding past each other as they move, well, now those borate ions are causing the polymers to get stuck to each other. So now those molecules, well, they're forming kind of larger molecules that are all stuck together there. Now you can see we've started to get some slime, right? It's getting stuck to our bowl. It's all stuck together. Alright, now once you've gotten to this point that you've mixed it to where it's starting to get stuck to the sides, this is where we get messy. So you're not really going to be able to mix it with your spoon anymore. So set your spoon aside, and now we get to get our hands dirty. And you're going to have to kind of get in there and knead that slime and kind of mix it all together. Woo! That's some fun stuff, isn't it? So this is now a new chemical substance. We have created a chemical reaction that changed the bonds within those polymers. So it has created this new substance. And the more you work it, the more it will be able to just stick to itself, and it won't necessarily stick to your hands quite as much. Now as you work with it, if it's maybe a little bit too runny and sticky and not firm enough for you to be able to really manipulate it, you can add a little bit more baking soda or a little bit more saline solution. If, on the other hand, it's gotten too firm and too rubbery and it doesn't really stick anymore, well, then you can add a little bit more water to it. I'm going to add just a touch more baking soda so that it can really be nice and firm. Now this may feel like, if you've ever done some cooking or baking, it probably feels a little bit like maybe some bread dough or something like that. It's probably a little bit stickier, okay, and that's because we're not actually going to bake it into anything. But this is a similar idea to when you're making bread dough. Now I wouldn't recommend cooking it and trying to eat it, because it's not going to taste good at all. And it's not going to be healthy for you either. But the next time you're baking something with your parents, remember, you've created some cool chemical reactions here. Now, this chemical change has been pretty dramatic, right? Like, we have really changed what we started with into something entirely new. But I want to show you that physical change, even though we're not actually creating new substances, sometimes a physical change can be just as or even more dramatic than a chemical change. Just by introducing a different molecule into a mixture or changing the phase or state of a type of molecule, well, you can have something really different, right? And that's why ice is really different from water, which is really different from water vapor. But now what we are going to do, we are going to introduce a physical change using our shaving cream. Now, what is shaving cream? Well, really it's just some water, a thing called stearic acid, some other little things like fragrances and stuff. But when it's put into a can like this, when you spray it out, all of those things are injected with a lot of air molecules. So, let's watch what happens when we mix those with our slime. Now try to kind of fold that shaving cream into it. So the water and the stearic acid inside the shaving cream is what allows the shaving cream to mix into the slime. But then, what happens? Well, as I said, we introduced a lot of air molecules into our slime with that shaving cream, right? And so now, instead of being slimy, we have foam, right? We have this really cool puffy slime that is more like foam. Look at that, it stretches and bends and mixes. Now see, mine's still a little bit sticky, so I probably can add just a little bit more shaving cream to it. Yeah, there we go. So now it's not too sticky anymore. It still does a really good job of sticking to itself, but it doesn't stick to me as much, and it doesn't stick to the bowl as much either. Now we have this nice, stretchy, fun foam you can make into all kinds of shapes, and you can stretch it and play with it. You can do all kinds of things with this foam. But if you were to look at these molecules, the chemical makeup of this substance is actually going to be the same as what our slime was. The only difference now is that we have lots of air molecules, okay, carbon dioxide, oxygen, nitrogen, from our shaving cream that have gotten mixed in between our other slime molecules. So now there's air molecules in the way here, and that makes it all puffy and gives it this really cool, unique texture. So again, this last part is actually only a physical change. Okay, we've created a different type of mixture of substances. We haven't changed any of the chemical compounds within our substance. It's just physical. Alright, I hope this has given you a better understanding of the differences between physical change and chemical change, and what a chemical reaction is actually doing to the substances. Also, I hope you had a lot of fun making our sticky, gooey, fluffy slime. Thank you so much for joining us, and we'll see you next time. Bye!